Good afternoon, students. Welcome back to the class. In this class we solve some problems on the complex numbers and their properties. Here is the first problem. If Z1 is equals to A plus IB, Z2 is equals to C plus ID, then Z1 is greater than Z2 is meaningful if so the answer is Z1 is greater than Z2. This implies A plus IB is greater than C plus ID if B is equals to 0 and A is greater than C. Second problem. Find 1 plus I by 1 minus I whole to the power of 4 plus 1 minus I by 1 plus I whole to the power of 4. Solution. Since 1 plus I by 1 minus I is equals to I, 1 minus I by 1 plus I is equals to minus I. This is equals to I to the power of 4 plus minus I whole to the power of 4. So this is equals to I to the power of 4 plus I to the power of 4, which is equals to 2 into I to the power of 4. This is equals to 2 into 1, which is equals to 2. Since I to the power of 4 is equals to 1. Third problem. If A square plus B square is equals to 1, then find 1 plus B plus AI by 1 plus B minus AI. Solution. A square plus B square is equals to 1. This is given. Consider 1 plus B plus AI by 1 plus B minus AI. This is equals to multiplying and dividing by the conjugate of the denominator. So 1 plus B plus AI whole square by 1 plus B whole square plus A square. This is equals to 1 plus B whole square minus A square plus 2IA into 1 plus B whole by 1 plus B square plus 2B plus A square. This is equals to 1 plus B square plus 2B minus A square plus 2IA into 1 plus B whole by 1 plus a square plus b square plus 2b. A square plus b square is equals to 1 and a square is equals to 1 minus b square. So this is equals to 1 plus b square plus 2b minus of 1 minus b square plus 2ia into 1 plus b whole by 1 plus 2b. This is equals to minus 1 plus 1 get cancelled. Minus of minus b square is b square plus b square 2b square. So 2b square plus 2b plus 2ia into 1 plus b whole by 1 plus 1 is 2, 2 plus 2b. Here 2 get cancelled. This is equals to b square plus b plus ia into 1 plus b whole by 1 plus b. This is equals to b is common, b into b plus 1 plus ia into 1 plus b by 1 plus b. So this is equals to b plus 1 into b plus ia by b plus 1. b plus 1 get cancelled. This is equals to b plus ia. Fourth problem. If sine inverse of z minus 1 by I, where z belongs to the set of complex numbers, can be the angle of triangle if solution let sine inverse of z minus 1 by I is equals to alpha. This implies sin alpha is equals to z minus 1 by I, so which is real, Consider z minus 1 by I is equals to z minus 1 by I into I by I, multiplying and dividing by the imaginary unit I by I. So this is equals to I into I square, so minus 1. So this is I minus IZ. This is equals to I minus I into Z is X plus IY. This is equals to I minus IX minus I into I, which is minus I square, which is plus Y. So this is equals to Y plus I into 1 minus X is real implies 1 minus x is equals to 0. This implies x is equals to 1. Therefore, real part of z is equals to 1. So, sin alpha is equals to sin y. This implies minus 1 less than or equal to y less than or equal to 1. This is y. So y lies between minus 1 and plus 1. So y is nothing but the imaginary part of z. The imaginary part of z. So minus 1 less than or equal to y less than or equal to 1. Therefore, minus 1 less than or equal to imaginary part of z means less than or equal to 1. Next, fifth problem. Find the smallest positive integer n such that 1 plus root 3i whole to the power of n by 2 is real. Solution. Consider 1 plus root 3i. This is equals to multiplying and dividing by 2. So 1 by 2, 2 into 1 by 2 plus root 3 by 2 into I. So this is equals to 2 into 1 by 2 in terms of cos. Again root 3 by 2 in terms of sine. So this is cos pi by 3 plus I sine pi by 3. Therefore 1 plus root 3 I whole to the power of n by 2 is equals to 2 to the power of n by 2 into cos pi by 3 plus I sine pi by 3 whole to the power of n by 2. This is equals to applying De Moivre's theorem, 2 to the power of n by 2 cos n pi by 6 plus I sine n pi by 6. So this is real, implies the imaginary part is equals to 0. So 2 to the power of n by 2 into sine n pi by 6 is equals to 0. This implies sine n pi by 6 is equals to 0. Therefore, n is equals to 6 is the smallest positive integer n such that 1 plus root 3i whole to the power of n by 2 is real. Next, sixth problem. Sixth problem. Find the imaginary part of 1 by 1 minus cos theta plus I sin theta. Solution. Consider 1 by 1 minus cos theta plus I sin theta this is equals to multiplying and dividing by the conjugate conjugate of the denominator. So 1 minus cos theta minus I sin theta whole to the power of 1 minus cos theta whole square plus sin square theta. This is equals to 1 minus cos theta minus I into sin theta whole by 1 plus cos square theta minus 2 cos theta plus sin square theta. This is equals to 1 minus cos theta minus I into sin theta whole by cos square theta plus sin square theta is 1. 1 plus 1, 2. 2 minus 2 cos theta. 2 is common. 2 into 1 minus cos theta. Therefore, imaginary part of 1 minus cos theta minus I into sin theta by 2 into 1 minus cos theta. This is equals to minus sin theta whole by 2 into 1 minus cos theta. Simplifying further and using the submultiple angles, so minus 1 into sin theta is 2 sin theta by 2 cos theta by 2 whole by 2 into 1 minus cos theta is 2 sin square theta by 2. 2 to get cancelled, 1 sin theta by 2 get cancelled. This is equals to minus 1 by 2 into cos theta by 2 whole by sin theta by 2, which is equals to minus 1 by 2 cot theta by 2. Three I cube plus 4 I to the power of 4 plus dash dash up to 200 terms. 200 terms. So solution given series I plus 2i square plus 3i cube plus 4i to the power of 4 plus dash dash, writing the last 4 terms. So 197i to the power of 197 plus 198 into I to the power of 198 plus 199i to the power of 199 plus 200 into I to the power of 200. So this is equals to since I to the power of 4 is equals to 1, I to the power of 4n is equals to 1 for all n belongs to n. Therefore I is common. So 1 plus 5 plus 9 plus dash dash plus 197 plus I square is common. So 2 plus 6 plus 10 plus dash dash plus 198 plus I cube into I cube is common. 3 plus 7 plus 11 plus dash dash plus 199 plus I to the power of 4 is common. So 4 plus 8 plus 12 plus dash dash plus 200. Here I coefficient, I square coefficient, I cube coefficient, I to the power of 4 coefficient is a finite arithmetic progression in which in the first I coefficient the first term is 1 and common difference is 4. Here the first term is 2 and the common difference is 4 and last term is 198. Here last term is 197. Here first term is 3, last term is 199. Here the first term is 4 and the last term is 200. In all the cases the common difference is 4. So since Sn AP is equals to n by 2 into A plus L. N is the number of terms in the progression, A is the first term, L is the last term. So this is equals to I into 50 into 99 plus I square into 50 into 100 plus I cube into 50 into 101 plus I to the power of 4 into 50 into 102. So this is equals to 50 is common. So 99I. Here I square value is minus 1. Minus into plus minus. So minus 1 into 100 minus 100. Next I cube is minus I. So minus I minus into plus minus. So minus 101 I to the power of 4 value is 1. So 1 into 102 plus 102. This is equals to 50 into minus 101 I plus 99 I, which is minus 2I, plus 102 minus 100, which is 2. So 2 minus 2I. This is equals to 50 into 2 into 1 minus I, which is equals to 100 into 1 minus I. So this is the required answer for the given sum of the series. Next, seventh problem. If A plus IB plus I square C plus I cube D is equals to x plus IY whole square, then find square root of A minus IB plus I square C minus I cube D. Solution. Consider A plus IB plus I square C plus I cube D is equals to X plus IY whole square. So this implies A plus IB, I square value is minus 1 into plus, so minus C, I cube value is minus ID is equals to X plus IY whole square. So this implies A minus C plus I into B minus D, this is equals to X plus IY whole square. Therefore consider A minus IB plus I square C minus I cube D is equal to A minus IB minus C plus ID. This is equals to A minus C minus I is common, B minus D. So this is equals to, so this is 1. From 1 it is X minus IY whole square since 1. Therefore square root of A minus C minus I into B minus D is equals to X minus IY. Next problem. Next problem, eighth one. If 1 plus I into X minus I by 2 plus I plus 1 plus 2I into Y minus I by 2 minus I is equals to 1, then find X comma Y. Consider the first term. I am multiplying, dividing by the conjugate of the denominator. So this will be 1 plus I into X minus I into 2 minus I by 5. 2 plus I into 2 minus I, which is 5, plus consider the second term, again multiplying and dividing by the conjugate of the denominator, 1 plus 2I Y minus I into 2 plus I by 5 is equals to 1. So this implies 1 plus I into 2 minus I into X minus I into 2 minus I. So 1 plus I into 2 minus I into X minus I into 2 minus I plus 1 plus 2I into 2 plus I into Y minus I into plus I. Here 5 is the denominator, so LCM. So 1 into 5, which is equals to 5. Simplifying the left hand side expression. So 1 plus I into 2 minus I, which is 2 minus I plus 2I minus I square, which is plus 1 into x minus 2I plus minus I into minus I, which is plus I square, which is minus 1, plus 1 plus 2I into 2 plus I. So 2 plus I plus 4I, 2I into 2I square, which is minus 2 into y minus I into 2 plus I, which is minus 2I minus I square, which is plus 1, is equals to 5. This implies 2 plus 1, 3, 2I minus I, which is plus I into x. Here plus 1 minus 1 get cancelled. Minus 2I, which is minus 4I. Again minus 2 plus 2 get cancelled. 4I plus I, 5I. 5I into y. So 5I into y, which is equals to 5. So this implies 3 into x, 3x plus I is common, x plus 5y minus 4 is equals to 5 plus 0 into I. So this implies 3x is equals to 5 and x plus 5y minus 4 is equals to 0. So solving these two equations. So 3x is equal to 5. So x is equals to 5 by 3. So 3x is equals to 5. This implies x is equals to 5 by 3. So put x is equals to 5 by 3 in x plus 5y minus 4 equal to 0. So this implies 5 by 3 plus 5y minus 4 is equals to 0. This implies 5y, 3 4s are 12, minus 12 plus 5 is minus 7 by 3 is equals to 0. This implies y is equals to 7 by 15. Therefore, x comma y values are 5 by 3 comma 7 by 15. Next problem, 9th problem. So 9th problem. If the square root of x square by y square plus y square by x x square plus 31 by 16 plus 1 by 2i into x by y plus y by x is plus or minus x by y plus y by x minus I by m. Then find m. So this expression is square root of this expression is so and so. So solution, consider the whole square of this expression. Consider x by y plus y by x minus I by m whole square. So this is equals to, this is a minus b whole square. So x by y plus y by x whole square plus b square. So here minus I by m whole square, which is I square by m square. I square value is 1, minus 1. So minus 1 by m square minus 2i by m into x by y plus y by x. So this is equals to a plus b whole square, x square by y square plus y square by x square plus 2 minus 1 by m square minus 2i by m into x by y plus y by x. This is given as x square by y square plus y square by x square plus 31 by 16 plus 1 by 2i into x by y plus y by x. Now comparing the or equating the real parts and imaginary parts, equating real and imaginary parts on both sides. So 2 minus 1 by m square is equals to 31 by 16 . So this implies 1 by m square is equals to 2 minus 31 by 16, which is 1 by 16. This implies m square is equals to 16. This implies m is equals to plus or minus 4. Or equating the imaginary parts. See, here multiplying and dividing by I. So I square is minus 1. So minus I by 2. So coefficient is minus 1 by 2 minus 1 by 2 into x by y plus y by x is equals to minus 2 by m into x by y plus y by x. This implies minus 1 by 2 is equals to minus 2 by m. This implies m is equals to 4. So these are this class. We will be back in the next class.